All right, welcome back. So today we are going to be talking about a subtopic of arithmetic sequences, and that's how to find the number of terms that are in an arithmetic sequence. If you have no idea what an arithmetic sequence is, I've linked the video I go through explaining what an arithmetic sequence is above, but we're only going to be talking about arithmetic sequences right now. We're not going to be talking about how to find the number of terms in the geometric sequence. That gets very involved. That might appear later in the year, but for right now, we're only going to try and work with arithmetic sequences. So in this example, it says, given the sequence, how many terms are there in the arithmetic sequence? To refresh your mind, our formula is a sub n is equal to the first term, a sub 1, plus the number of terms minus 1 times our common difference. So with our common difference, I'm going from 2 to 5, 5 to 8, 8 to 11, so on and so forth, and every single time I'm adding 3. So my common difference here is going to be 3. And we want to figure out how many terms there are. So we want to actually solve for n. A sub n is the end point, pretty much. So what we want to use is a sub n. We're actually going to replace that with 35, because 35 is the end of the sequence. We know that the first term is going to be 2, and we don't know n. So we eventually want to be solving for n. So our formula here, or our equation, I should say, is going to look like such. 35 is equal to our first term, 2, plus n minus 1 times our difference of 3. Now we want to solve for n here. There's a bunch of different ways to go about it, but you're just solving for n. So what I'm going to personally do is I'm going to distribute 3 inside my set of parentheses, and at the exact same time, I'm going to be subtracting 2 on both sides. So I eventually get 33 is equal to 3n minus 3. From here, I can add 3 to both sides. I get 36 is equal to 3n. N is equal to 12. So there are going to be 12 terms in this sequence. That's all. That's all it is. Here is another example. Given the sequence, how many terms are there in the arithmetic sequence? So again, we start out a sub n equal to a sub 1 plus n minus 1 times our difference, and we fill in what we know. Well, a sub n is that last term, so negative 56. A sub 1 is that first term, which is 14. We don't know n. But our difference here, 14 to 9, 9 to 4, we're subtracting 5. So our difference is going to be negative 5. I'm going to put that in parentheses. Okay, and what I'm going to do again is I'm going to distribute this negative 5 into my parentheses, and I'm going to be subtracting 14. So when we do that, negative 56 minus 14 is negative 70, is equal now to negative 5 n plus 5. Remember, because negative 1 times negative 5 is positive 5. All right, so now we want to solve for n. I'm going to add 5. I'm going to subtract 5 on both sides. I get negative 75 is equal to negative 5n. I divide both sides by 5, and then I get that n is equal. That should be 15. Yep. N is equal to 15. So there are 15 terms in this sequence. That's all. All right, folks. Great job today. If you have any questions, please feel free to reach out. Again, this is just arithmetic sequences, not geometric sequences. Great job today, folks. Have a good one.